The debate In 1924, Hubble wrote to Shapley to share his findings. The evidence was overwhelming. The universe was not limited to the Milky Way. It was filled with galaxies beyond count, stretching outward into immensity. Shapley, confronted with the undeniable, is said to have remarked, "Here is the letter that destroyed my universe." It was a moment of extraordinary humility, a recognition that a lifetime of reasoning had been overturned by the stubborn testimony of the stars. In science, even the grandest ideas must yield to observation. The revelation did not merely enlarge the universe, it transformed our place within it. The Earth was already known not to be the center of creation, but now even the Milky Way was stripped of cosmic centrality. Our galaxy was one among billions, perhaps trillions, each with its own suns, its own planets, and its own stories written in light. The debate between Shapley and Curtis had ended not with a handshake, but with the sky itself speaking the truth. From that point forward, the cosmos could never again be imagined as small or parochial. Hubble's discovery set the stage for even greater revelations. Once astronomers accepted that galaxies were independent systems, they began to ask whether they were moving, and if so, how. Within a few years, Hubble himself would reveal the expansion of the universe, opening the path to the theory of the Big Bang. But it all began with the quiet pulse of Cepheid stars in Andromeda, faint flickers that carried the weight of truth across the void. The Great Debate had framed the question, but Hubble's lens provided the answer. In lifting the veil, he widened the stage of existence and invited us to confront the staggering immensity of the real universe. The story of the Great Debate and the triumph of observation is more than a tale of two men and a single telescope. It is a parable of science itself, showing how even deeply held convictions must bow to evidence, and how the cosmos has a way of humbling us whenever we think we have reached its limits. In the light of Cepheids and the courage of those who looked through the Hooker telescope, the universe expanded from a bounded system into a vast ocean without shores. From that moment, humanity stepped into a cosmos immeasurably grander than anything Quinn had imagined in his Atlas of Light. When Edwin Hubble revealed that the universe was filled with galaxies, the question immediately arose: how far could we see? The night sky, once thought to be a dome just beyond the clouds, now stretched into unimaginable distances. As telescopes reached deeper, astronomers realized that every increase in power revealed yet more galaxies, as though the cosmos had no edge. Yet logic suggested that there must be a limit, not because space itself ended, but because light takes time to travel. We can see only as far as light has had time to reach us since the birth of the cosmos. This horizon of visibility is known as the observable universe. It is not a physical wall, nor a curtain we might pierce with better instruments. It is simply the boundary defined by time. If the universe began at a finite moment in the past, then only light that has had enough time to journey since that beginning can be seen. In the middle of the 20th century, theorists predicted that the sky should be filled with a faint echo from the first fireball, radiation stretched into microwaves by the long expansion of space. If discovered, this afterglow would mark the true edge of our observations. In the year 1964, two engineers, Arno Penzias and Robert Wilson, stumbled upon this signal while testing a radio antenna in New Jersey. No matter where they pointed, the instrument detected a hiss of microwave noise. What seemed at first a technical problem turned out to be the whisper of creation itself, the cosmic microwave background. Its light had traveled for more than 13 billion years, released when the young universe cooled enough for atoms to form. The discovery confirmed the Big Bang and set a horizon beyond which no telescope could see.